My dear students, I am Suguna Reddy, Assistant Professor, Department of Mathematics, GFGC and PG Center, Chintamani, Chikkaballapur District. In this video, I am going to work out a problem based on Stokes' theorem. Stokes' theorem states that the surface integral of the curl of a function over a surface bounded by a closed surface is equal to the line integral of the particular vector function around that surface. Stokes' theorem formula is like this. A line integral over a closed surface of f dot dr is equal to double integral over the surface S of del cross f dot n ds. Del cross f means curl. Now let us evaluate a problem based on Stokes' theorem. Evaluate by using Stokes' theorem a line integral over a closed curve C of sin z dx minus cos x dy plus sin y dz, where C is the boundary of the rectangle lying between x lies between 0 to 5 and y lies between 0 to 1 and z is equal to 3. By Stokes' theorem, we have a line integral over a closed curve C of f dot dr is equal to double integral over the surface S of curl dot n ds. It is given a line integral over a closed curve C of sin z dx minus cos x dy plus sin y dz. This function can be written as sin z I minus cos x j plus sin y k dot dxi plus dyj plus dzk. So this is nothing but the dot product of f dot dr. So the given integral, that is the integral over a closed curve C of sin z dx minus cos x dy plus sin y dz is written as a line integral over a curve C of f dot dr, where f is a function, that is sin z I plus cos x j plus sin y k, and dx dy dz is nothing but dr, where f is equal to sin z I plus cos x j plus sin y k. Find out the curl of this function, that is del cross f is equal to I j k dou by dou x dou by dou y dou by dou z, and I j k coefficients of f are sin z, cos x, sin y, that we have written in the third row. Now by evaluating this, that is I into dou by dou y of sin y minus dou by dou z of minus cos x. See, by evaluating this, we get I into cos y minus 0. Dou by dou y of sin y is cos y. Dou by dou z of minus cos x is 0. Then the next term with the j, that is minus j into dou by dou x of sin y, dou by dou z of sin z. Dou by dou x of sin y is 0. Then dou by dou z of sin z is cos z. Then with the k, dou by dou x of sin y, dou by dou z of this one. So k into dou by dou x of cos x minus cos x is sin x, dou by dou y of sin z is 0. Now by simplifying this, we get cos y I plus cos z j plus sin z k. So this is the curl of the given function f. So del cross f is equal to cos y I plus cos z j plus sin x k. Now by the formula we have del cross f dot n. Here we have considered the curve along with the xy plane, then the normal vector will be k. The boundary of the rectangle C is x is lying between 0 to 5 and y is lying between 0 to 1. Exactly this lies in the plane z is equal to 3, which is parallel to xy plane. Therefore, the unit normal vector drawn to S is k. So that is n is equal to k. Since the boundary of the rectangle, that is x varying from 0 to 5 and y varying from 0 to 1 lies in a plane z is equal to 3 which is parallel to xy plane. Therefore, the unit normal vector for this surface S is equal to k. That is nothing but n is equal to k. Now, we have del cross f dot n is equal to cos yi plus cos zj plus sin x k dot n. Dot n means it is dot k. When you find out the dot product with the k, so k dot I is equal to 0, k dot j is equal to 0. Therefore, we get sin x since k dot k is equal to 1. So, this is equal to sin x. Now, we have a line integral over the closed curve C of f dot dr is equal to double integral over the surface S of del cross f dot n ds by the Stokes theorem. Now, let us take the RHS, that is the double integral over the surface S of del cross f dot n ds, and simplify to find out the line integral of f dot dr. RHS is del cross f dot n, which is sin x. So, double integral over the S of sin x dx. Then, we will take the limits as x varying from 0 to 5 and y varying from 0 to 1 sin x dx. Because the surface S is the boundary of the rectangle where 0 greater than or equal to x less than or equal to 5, 0 less than or equal to y is less than or equal to 1. Hence, x varies from 0 to 5, y varies from 0 to 1 sin x dx dy. See, ds is replaced by dx dy since the surface is lying in the xy plane. Now, by evaluating this, we get integral x varies from 0 to 5 sin x dx and integral 0 to 1 dy. By simplifying this, we get minus cos x and limits of integration are 0 to 5, then y limits 0 to 1. By simplifying this, we get minus cos 5 plus cos 0. See, when we apply the upper and lower limits, cos 5 plus cos 0, and the next term, it is upper limit 1, lower limit 0. So, 1 minus 0. Now, cos 5 value is minus 1, then cos 0 value is 0, cos 0 value is equal to 1. So, minus cos 5 value is minus 1, cos 0 value is 1. So, minus of minus 1 plus 1 into 1. So, which is nothing but 2. You will get. Hence, the line integral over a closed curve C of f dot dr is equal to 2. This is the required result. Thank you.